Hello, everyone, and welcome to our first discussion about trigonometry, which is angles and angle measures. The first topic, the first subtopic that we will discuss today is about degrees in radians. So, so far, what do we know about angles? Let me recall the definition of trigonometry that I mentioned in the last time. From the last video that I made, which is the introduction of trigonometry. Trigonometry is basically about the study of triangles and its sides, angles, and the relationship between the sides and angles. And I illustrated what angle looks like. So I'm going to recall the example that I used to describe how angles were formed. So we have two given rays, all right? Here we have the first ray here, which is the initial side, or IS in short. The initial side, basically, it is a side that it will not move, all right? Then we have a side that, let's just say, intersects at this point, and it is also a ray. And this side is the terminal side. And here, this side, to be particular, the terminal side, we can rotate it. We can rotate it outward, or basically in a counterclockwise direction or in a clockwise direction. All right. So here you see, no matter how far they are to each other, no matter how far the terminal side to the initial side, or no matter how far the initial side to the terminal side, they always form an angle. No matter how far they are, there is always a given angle for them. The angle tells how far they are to each other. The distance between the two, but in a angle way, basically. So here, let me just put some few details. Why is it called initial side? Because we all know that initial side is basically the starting side. So it does not necessarily imply that it is a side that is immovable, right? So why is it called initial side when I mentioned that this side will not move? So basically, think of it this way. For example, this is you, right? This small dot, right? That's you, basically. Now, imagine that you rotate yourself in a counterclockwise direction. Let's assume that you rotate until here, right? You rotate until here. So here, this is your terminal side. And this, the dot, basically where you start is your initial side. Do you understand? So initial side is basically your starting, how should I say this? Your starting side, while the terminal side is actually the finishing side. All right. So there's also another detail that I would like to add as well, that there are angles that the way how they form, it doesn't look like this. It can be formed like this, like in a V shape, like this, right? We have an angle here, all right? Then there are moments where the angle look like this one. Then we have this one. And the angle formed here is actually this one. You see, there are moments where angles would look like either this, and other illustrations of how angles were formed. All right, but uh, how should I say this? They still imply the same thing. All right. Again, as I said earlier, no matter how far the two sides to each other, there's always an angle between them. Just like this, for example, they may be in a V shape, but the angle between them tells how far they are. The same thing here to the third illustration. Here we have two rays that are very far apart to each other, but they still form an angle, right? So yeah, I'm just basically reminding you that not all depictions or illustrations of angles are the same, all right? But in the meantime, we will focus on this one because this is the standard way on how we are going to measure the angles, which is to be discussed later, right? So to sum up, basically, when two straight lines or rays intersect at a single point, an angle is created according to Splashner, right? So let's relate angles to the Cartesian plane. So let's have a short recall about Cartesian plane. So this one, I do believe that it is discussed in your algebra class, right? Or your algebra subject, right? So Cartesian plane look like this one, right? Looks like this one. Forgive my grammar mistake. So yeah, Cartesian plane looks like this one, right? It's a graph. And here, there are two axes. One is we have the y-axis and we have the x-axis. Y-axis, forgive me, y-axis is basically a vertical axis. Then the x-axis is basically the horizontal axis. All right. In here, the intersection between the y-axis and x-axis form a four quadrants. All right. Basically, what I'm trying to imply here is that due to the intersection of these two axes, there are four quadrants. This one, this one, and this one are formed. All right. So let me name these quadrants. We have this one, the first quadrant, the top left, the second quadrant, third, which is on the bottom left, is the third quadrant, and the fourth, which is located on the bottom right, this is the fourth quadrant. Okay, so here's the thing though. Why do we relate angles or use angles with the application of Cartesian plane? Think of it this way. We use Cartesian plane as a protractor. If you don't know, protractor is basically a measurement used to measure an angle. All right? So basically, yeah, think of it that way. All right? Or if you don't know what protractor is, think of it this way. We will use Cartesian plane to measure angles. I think that would be far better. All right? For no more complicated statements, right? So here, we can use Cartesian plane to form angles, which is actually has a lot of benefit to it because these are all useful to our future lessons, all right? Especially if you're going to, how should I say this? If we're going to apply in real life situation, yeah, it's actually useful. All right. So anyway, yeah, that's the first thing. All right. The first thing is uh, the application of Cartesian plane in forming angles are very useful. All right. So think of it as if it is a protractor. Right. Think of it as if this is the way how you will measure angles. Then we have the second reason, which is the rotation. All right. So let me draw the, how should I say this? The two sides. We have the blue ray, which is the initial side. Then we have the red ray, which is the terminal side, right? And remember, no matter how far they will always form an angle, right? See? Now, here, the terminal side, if you recall, that side will be rotated or will be the one who will rotate itself. It could be in a counterclockwise direction or in a clockwise direction. So What if the terminal side rotates in a counterclockwise, or it rotates outwards, like basically going there, you know? So if the terminal side rotates at the counterclockwise direction, expect that the angle is positive. So for example, I will start from here, which is the initial side, then I will go from here. So there. So here, no matter how far they are, as long as it rotates outward, the angle formed here is positive. All right? So there we go. Counterclockwise rotation will give you a positive angle. Now, what if it's in reverse? Like instead of counterclockwise, it is in clockwise rotation. So starting from here, going there. So here, for a while, okay, let's continue. So here, if it rotates on a clockwise rotation, then we will have a negative angle. Again, no matter how far the initial side is to the terminal side, as long as the terminal side rotates in a clockwise direction, expect that the angle is negative. All right? So basically, that's it, right? So now, let's talk about how do we measure angles, all right? Especially with the application of Cartesian plane. So there are two ways on how to measure angles: degrees and radians, which is the first subtopic that we're going to discuss today. So let's first talk about degrees. So this is actually the common way to measure angles. I think I have already gave you some illustrations of how angle looks like in a triangle. Like for example, here we have a right triangle. If you see this one, this square figure, it means it is a 90 degree, right? 19-degree angle. Then here we have 30 degrees. Then here we have 60 degrees, all right? So here, as long as that we have a number and we have a symbol like this, which is this one, it means it is in degrees, all right? So for you to have another idea, I already mentioned this earlier. Imagine that you're using protractor. So protractor looks like this one, a semicircle figure, all right? So at this point, this one is 0 degree. So going upward, you will have 10 degrees, 20 degrees. Then midway, you will have 90 degrees. Then continuously, you will have 100 degrees, so on and so forth, until you reach the end point, which is 180 degrees. All right? So this one is useful actually. In fact, I do believe that many students in general are familiar with this measurements. All right, because these are useful in forming angles. Like for example, if you would use a pen, or let's just say pencil, and let's just say your teacher told you to form an angle of 20 degrees, so you're going to use your pencil here, then trace it up to here. That means you form an angle of 20 degrees. All right. So now let's relate it to the Cartesian plane. All right. So here, let me just label again the the types of quadrants: first quadrant, second quadrant, third quadrant, and the fourth quadrant. There you go. All right. And the positioning of the fourth quadrant sucks. So let me just rearrange it again. I'm back. So in here, we're going to focus on the basic angles that you need to know. One of it is the angles located at the axis, all right? The x-axis and the y-axis. So here, at the starting point, you have 0 degrees. midway, you have 90 degrees. Here, going back to the x-axis, you will have 180 degrees. Here, going at the y-axis but below, you will have 270 degrees. And going back to 0 degrees, you will form 360 degrees. Meaning, if this is your initial side, let me just draw again. If this is your initial side, okay, let blue ray be the initial side. If this is your initial side and you rotate in one rotation, basically you rotate in one rotation, that means you form an angle of 360 degrees. So one whole rotation, you form an angle of 360 degrees. All right. So now let's be more detailed when it comes to measuring angles. So let's just say that you form an angle because the terminal side is in here and it is rotated in counterclockwise direction. So let's focus first on the counterclockwise direction, all right? So counterclockwise direction, your terminal side is located at the first quadrant. So what would be the exact angle to it? Or if not exact, what would be the range of angle in the first quadrant? So to answer that question, angles in the first quadrant is greater than 0 degrees but less than 90 degrees. Again, on the first quadrant, okay, here on the first quadrant, right here, the angles formed here are greater than 0 degrees but less than 90 degrees. All right, so for example, from here to there, you form an angle of, let's just say, 46 degrees. So that means that angle is located at the first quadrant. All right? Now next, what if it goes further? Like it's greater than 90 degrees. All right? It goes further, like let's just say it goes here. All right? And again, it is rotated in counterclockwise direction, okay? We're still in a counterclockwise. So if the terminal side is located at the second quadrant and it is rotated in counterclockwise, then the angle here is greater than 90 degrees, but less than 180 degrees. So you can have, let's just say 120 degrees, maybe 100 degrees, maybe 150 degrees, so on and so forth. All right? So basically, that's it. Okay? Now, how about if it goes greater than 180 degrees? Like you go even further and you stop right here. So that means the terminal side is located in a third quadrant. So here, the angles formed are in between 180 degrees and 270 degrees, but the ends are not included. Basically, in other words, the angles formed here are greater than 180 degrees, but less than 270 degrees. So for example, let's just say we have 250 degrees. We have 200 degrees. We have 199 degrees, and so on and so forth. And lastly, what if it goes even further? Like it goes, how should I say this? It goes like from your initial side going to the terminal side that is located at the fourth quadrant. Therefore, the angle formed here, okay, the angle formed here is greater than 270 degrees, but less than 360 degrees. Again, the angle formed here is greater than 270 degrees, but less than 360 degrees. So to sum it up, if it's in a counterclockwise rotation, then you have these given angles. All right, I mean given ranges of angles. All right. So let's have like a, how should I say this? A short practice though. All right. Let me just throw. Okay, there you go. Let's just say that the angle that you form is 280 degrees. Where do you think the terminal side is located? Is it in the first quadrant, second quadrant, third quadrant, or fourth quadrant? Let me repeat the question. If the angle formed is 280 degrees, where does it locate? I mean, where is it located? I mean, is it in the first quadrant, second quadrant, third quadrant, or fourth quadrant? The answer is in the fourth quadrant. Because remember, angled form greater than 270 degrees but less than 360 degrees is located in the fourth quadrant. So let's just assume that this is the graph. Okay? Let's just say this is, there you go. The angle form here is 280 degrees. Right? So see, that's it. Right? You just know, you just need to know this one. All right? Do not forget this. Now, what if we are asked to rotate it in a in a clockwise rotation? So remember that in a counterclockwise rotation, we will have positive angles. But what if it's in clockwise? If it's in clockwise, then that means we will have a negative angles. So here we will have different angles to the axis. All right. So as usual, we will have, wait, forgive me, wait, there we go. As usual, we will have 0 degrees as a starting point. But if we're going to rotate again in the clockwise direction, then we will have 90 degrees below the y-axis. Then here, on the left x-axis, we will have negative 180 degrees. Then the top of the y-axis, we will have negative 270 degrees. And going to the 0 degrees, you will have negative 360 degrees. So it's basically like a reverse of the counterclockwise rotation angles, you know? It's like a reverse, all right? It's just that the positioning and the signs are different, all right? Or opposite, I mean. So let's just say you start on the initial side, then you form an angle in the fourth quadrant, all right? Because when you, let's just say, how should I say this? When you start uh, moving the terminal sides on a inward direction or in a or in a clockwise rotation, the first quadrant that you will approach or you will proceed is the fourth quadrant, or you'll start from here basically. So in here, if if your terminal side is located at this quadrant, expect that the angle formed here is less than 0 degrees but greater than negative 90 degrees. All right? Again, less than 0 degrees but less than negative 90 degrees. But what if it's exceeds further, like it reaches less than negative 90 degrees? Okay? Therefore, it reaches the third quadrant. So here, you will have an angle that is that is less than negative 90 degrees, but greater than negative 180 degrees. That's for the third quadrant. Now, what if you even exceeded further, that you reach the second quadrant? So in the second quadrant, the angles here are greater than, here we go again. The angles here are less than negative 180 degrees, but greater than negative 270 degrees. That's for the second quadrant. If you choose to put your terminal side at the first quadrant, while you rotate it in a clockwise direction, then the angles in the first quadrant are less than negative 270 degrees, but greater than negative 360 degrees. Or to sum it up, this is the ranges of the angles, right? So if it's in the clockwise rotation, we will have negative angles. First quadrant, angle is less than negative 270 but greater than negative 360. Second quadrant, less than negative 180 but greater than negative 270. Third quadrant, less than negative 90 but greater than negative 180. And lastly, for the fourth quadrant, less than 0 degrees but greater than negative 90 degrees. So, for example, let's just say you form an angle this which is negative 156 degrees. Now, where do you think that this angle is located? Is it in the first quadrant, the second quadrant, third quadrant, or fourth quadrant? So to answer that question, the answer is in the third quadrant. So if you're going to graph it out, assumingly it would look like this way. So from the initial side, then going here. That's it. So this is negative 156 degrees. That's it, right? That's basically it, right? So these are the things that you need to know, all right, for you to measure angles, all right? So yeah, now that we know the ranges of angles when it comes to the rotation, what happens if the angle what happens if the terminal side coincides to the axis? Meaning, what if your terminal side is at the y-axis or in the x-axis? So that's a good question. Okay. So let me erase this one. Right? Okay, let me erase the angles as well. Right? So let's just say you're in the counterclockwise rotation. Then your angle is stopped exactly at this y-axis. So you stop right here. So it's exactly at the y-axis. Okay? Or maybe you start from here, then you would rotate it inwards or clockwise, then you would stop at the x-axis, right? So you will form like this, right? So here, where does it located? You know, like what can we say about these angles? So here, these angles are neither located at the first quadrant, second quadrant, third quadrant, nor fourth quadrant. All right, it is not located in the first, second, third, fourth. No, but rather it is located at the axis. So if the terminal side coincides to an axis, whether if it's y-axis, x-axis, or whatsoever, it will form a quadrantal angle. All right? So in other words, if the terminal side locates at the y-axis, it will form a quadrantal angle. If the angle if the angle, no wait, if the terminal side is located at the x-axis or y-axis, it will form a quadrantal angle. Quadrantal angle. All right? So, for example, let's just say you start from here, then you form an angle at here, here exactly. So that means your terminal side stops until here. And remember that again, if the terminal side coincides to an axis, it will form a quadrantal angle. That means that here you will form a quadrantal angle. All right. So 0 degrees, 90 degrees, 180 degrees, then you have 270 degrees. That means 270 degrees is a quadrantal angle. All right. So basically that's it. Any axis, x-axis or y-axis, you will form a quadrantal angle. Okay. Just like this one. You rotate it in a counterclockwise, then you're going to stop at the below of the y-axis. You will form 270 degrees. So that 270 degrees is a quadrantal angle. All right. So we can simply imply that we have 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees, especially the negative ones, such as negative 90 degrees, negative 180 degrees, negative 270 degrees, and negative 360 degrees. These are quadrantal angles, all right? But remember, these are not the only angles that act as a quadrantal angle, okay? They're actually more than 360 degrees, all right? So we will discuss that later, right? Or maybe in the next video. Because you see, in the angles, we know the basic ones, which is basically from 0 degrees up to 360 degrees, which is basically, that's a basic thing. But you know, there are angles that are greater than 360 degrees, such as 400 degrees, 500 degrees, you know. So we will discuss that in the future. But for now, you should know the basics, right? So in here, what can we, how can we interpret degrees? So here, if you form a 1 degree angle, it means it is 1 out of 360 of a complete rotation. All right. Again, if you form a 1 degree of angle, that means it is 1 out of 360 of a complete rotation. All right. So for example, let's just say you form an angle of 90 degrees. Like for example, you start from here, then you stop at here. So you form 90 degrees. Remember that this is 90 degrees. All right. So what if you have 90 degrees? What can we say? So 90 degrees is the same as 90 all over 360 of a complete rotation. Okay? Of a complete rotation. Let me just write it here. Or we can simplify this one. All right? This one is just the same as 1/4. All right? So this is 1/4 of a complete rotation. Right? My handwriting sucks, so forgive me. But I guess you get the point. All right? I guess you get the point here. All right? So that means when you rotate 90 degrees, you just only rotate at 1/4 of it. You know, just rotate 1/4. Now, what if you form 180 degrees? So that means you have 180 out of 360 of a complete rotation. Or this is basically 1/2 of a complete rotation. 1/2 of a complete rotation. In other words, you just rotate halfway. You just rotated halfway, basically. All right? So that is how we interpret degrees when it comes to rotation. All right? So there are other things that we're going to discuss about degrees. All right? But for now, we're going to stop right here because at least you know how to understand this topic about degrees. That's the important part. All right. So we will continue this one in the future discussions. All right. So see you in the next part.